Assalamualaikum dan salam sejahtera. Hi guys, see you again in organic chemistry. Now we look at the new chapter, which is chapter 6, aromatic compounds. The things that we are going to focus now is nomenclature of aromatic compound and chemical reaction of benzene. So guys, let's start. Okay guys, before we look at the nomenclature of benzene, you need to know what is aromatic compound. So aromatic compound is organic compound that contain at least one benzene ring. So I know that you are very familiar with this benzene ring, which is the shape like hexagon shape, and inside the hexagon shape contain of 3 double bond. Okay, so they are called aromatic because of its odor. But now aromaticity refer to the stability of compound that are considered aromatic. So if that compound consists of aromatic ring or benzene ring, so that compound we call as aromatic compound. Okay, so now we look at the criteria of aromaticity. So we have 4 types of criteria of aromaticity, which is the first one, the molecule must be cyclic. Cyclic means that molecule must consist of ring, for example like benzene ring just now. And then number 2, the criteria should be planar. Okay, so planar means that all atoms in the molecule will lie in the same plane. Maksudnya dia macam rata kelas. Macam you all tengok piring, macam tu lah you tengok benzene ring sebenarnya kelas. Dia lepeh rata. Okay. Number 3, the criteria of aromaticity is completely conjugated. So what is mean by completely conjugated here is delocalized electron in compound with alternating single and multiple bond. Okay, for example like look at this benzene ring. So the double bond here is alternating with this single bond, double bond, single bond, double bond, single bond. So this is what it means by completely conjugated. So and then we have cyclobutadiene here. So this compound also completely conjugated because the double bond alternate with single bond. And then we have the bigger structure here, which is aniline. So aniline also is completely conjugated. So means these 3 compounds fulfill the 3rd criteria of aromaticity. And the last criteria of aromaticity is the number of pi electron must satisfy Hukel rule, which is the Hukel rule formula is 4n plus 2. How to apply this formula? I will teach you after this. Okay guys, look at this example. We have benzene here and cyclobutadiene. So if you look at the answer, we know that benzene is aromatic compound, but cyclobutadiene is not aromatic compound. Walaupun sebenarnya cyclobutadiene dah memenuhi syarat yang ketiga tadi. Kan pertama, kedua, ketiga dia memenuhi syarat. Tapi yang keempat, cyclobutadiene tidak memenuhi Hukel rule. So why? So look here. Okay, so if we look at in benzene, okay, so we have 3 double bond here. So inside this double bond, we know that consists of pi electron. Okay, so here also consists of pi electron. Here also consists of pi electron. So 1 pi, okay, 1 pi consists of 2 electron. So here we have 3 pi bond. So means that in benzene ring consists of 6 pi electron, while cyclobutadiene consists of 2 double bond here. So here we have pi, here also we have pi. So the total pi electron here only 4. Okay, so how to prove it? By using Hukel rule. Okay, just now we know that the formula of Hukel rule is 4n plus 2. They say that Hukel rule 4n plus 2 must equal to the number of pi electron. Okay, look at for benzene here. 4n plus 2 equal to 6. Okay, 6 refer to the pi electron inside the benzene ring. Okay, now you calculate the n. If you got the n is integer, means the value of n should be whole number. Kalau you dapat dalam bentuk perpuluhan atau pecahan, so itu tidak menepati Hukel rule. Okay, so n mesti integer, maksudnya dia mesti nilai nombor lah 1, 2, 3, 4, 5. You tak boleh dapat perpuluhan atau pecahan. Okay, so it means that this benzene ring will satisfy Hukel rule because the value of n is 1. While cyclobutadiene, the value of n that we got here is 0.5 or half. So this is not integer. Okay, so it means that cyclobutadiene doesn't fulfill any the fourth criteria of aromaticity. Okay, so dia tidak memenuhi syarat yang keempat. So that's why cyclobutadiene is not aromatic compound. So actually cyclobutadiene is alkene, right? Okay, so this is the Hukel structure for benzene. Okay, so if you draw the expanded structure for benzene, it should be like this. If you look here, we have 6 carbon here, and each carbon bonded to 6 hydrogen. So this is the general formula of benzene. Okay, we have 6 carbon and 6 hydrogen. Okay, so this is the skeletal structure of benzene ring that normally you dah biasa lukis. Okay, so the important thing that you need to know that if the ratio of carbon to hydrogen is very low, most probably there is a benzene ring in the compound. So kalau dalam soalan beri you all a general formula or molecular formula dan nilai ratio carbon, bilangan carbon dan bilangan hydrogen hampir lebih kurang sama, itu bermaksud in that compound should contain benzene ring. Okay, boleh? Okay, Hukel suggested that a fast equilibrium interconvert the two isomer. So this is the Hukel structure for benzene. Either you draw like this or you can draw like this. So actually the position of double bond boleh jadi berubah-ubah. Okay, class? Alright, so now we look at the resonance structure of benzene ring. Okay, we have two resonance structure of benzene ring because we can move the position of double bond. So kalau you still remember last semester, we already learned about this resonance structure. Ingat lagi tak? Kita tukar kedudukan double bond. So dalam benzene juga boleh berlaku resonance structure like this. Okay, so you can see here. So the other version of benzene ring you also can draw like this, but saya tidak begitu galakkan you draw like this. Okay, especially when we learn about mechanism later, so saya tak begitu galakkan you draw like this. So make sure biasakan diri you all draw the structure of benzene ring that consists of 3 double bond inside the hexagon shape. Alright, so the electron in pi bond are delocalized around the ring. Maksudnya dia boleh bergerak. Delocalized tu dia tak duduk setempat kan. Okay, because each pi bond has 2 electron, so benzene has 6 pi electron. Okay, we already discussed about this. So the circle represent, actually the circle inside the hexagon shape here represent the 6 pi electrons distributed over the 6 atoms of the ring. It means that the electron is delocalized into ring. Okay, so ini just general info saja untuk you all. Alright guys, now we are going to learn about nomenclature of aromatic compound. For me, nomenclature of aromatic compound much more easier compared to alkane and alkene. Okay, so let's start. Alright guys, so we look at the mono-substituted benzene. Mono-substituted benzene refer to the compound that contain only one branch. Dia cuma ada satu je cabang. Okay, for example, like this. Okay, so if you have only one substituent, benzene will be the parent name. Alright, so the substituent we indicate by a prefix, refer to your substituent. Okay, for example here, Okay, we have benzene ring here and we have one branch here or one substituent here. So this substituent we call as fluorine kan, ataupun bila kita jadi sebagai nama dia adalah fluoro. So benzene ring will be your parent name. So nama penuh dia akan jadi fluorobenzene. No space at all. Okay, so we need to write the name in single word. Okay, like alkene and alkene. Okay, the other version of example here, we have benzene and then we have here NO2 group directly bond with benzene. So NO2 group we call as nitro. So kita gabungkan dengan benzene, it should be nitrobenzene. Okay, next we have alkyl group here. See, so we have 2 carbon here. So this alkyl group we call as ethyl. So ethyl benzene. Yes, so very simple if you have only one substituent. Okay, so we have the other version of monosubstituted benzene. So however, IUPAC rule also allowed some common name to be retained. So I want you to memorize all these common name. Okay, because this common name will be your parent name. Okay, tak banyak pun. Okay, yang pertama cuma ada 6 je kat sini. Yang pertama kita ada methyl benzene. Okay, you boleh tulis sebagai methyl benzene, but tolong hafal nama yang biasa digunakan di dunia. Nama yang biasa kita guna adalah toluene. Okay, so if methyl group directly bond with benzene, we have the common name here. So use this common name as the parent name. Okay, so toluene. And then OH group directly bond with benzene, so this is called as phenol. And then NH2 amino group, okay, attached with benzene we call as aniline, or this is the real IUPAC name, aminobenzene. Okay, and then COOH directly bond with benzene we call as benzoic acid. Saya rasa you pernah dengar. Okay, so CHO, CHO ni adalah aldehyde class. If we expand the structure, so here should be C double bond O H. So this C is directly bond with benzene. Okay, so C tu yang sebenarnya directly bond with benzene here. Okay, and then we have acetophenone. So kalau yang ini tadi, yang ini tadi kita ada aldehyde. So yang hujung tadi ni kita ada ketone. Alright, so I want you to memorize all these 6 common name, because this common name will be your parent name. Okay guys, so now we look at the di-substituted benzene. It means that in benzene ring consists of 2 substituent or 2 branch. Okay, for example here, if we have 2 same substituent, okay, so look this statement, relative position of substituent are indicated by prefix ortho. Ortho means the position 1, 2. Meta means that the position is 1, 3. And then we have para is position is 1, 4. So this is the singkatan bagi ortho, meta, para, or by use of the numbering. Okay, so you can use ortho, meta, para, ataupun you boleh guna nombor, tak ada masalah. Tapi normally if we have 2 substituent, normally we are going to use ortho, meta, para. Okay, for example here we have 2 same substituent. We have bromine here. Okay, so if you look at the position of bromine atom at position 1 and 2. Okay, so either you name it as 1,2-dibromobenzene. Di refer to 2 bromine atom. Okay, or you can use ortho-dibromobenzene. So we replace the numbering 1, 2 here with ortho. Very simple kan? So remember, this ortho, meta, para only for benzene. Nanti jangan buat untuk cyclo pula ya. Cycloalkane, cycloalkene tidak ada ortho, meta, para. Ortho, meta, para only for benzene. Remember? Okay, guys? Okay, next, look at the position of bromine now. The position of bromine now at position 1 and 3. Look. Okay, so if position 1 and 3, either you name it as 1,3-dibromobenzene, or yes, you can use prefix meta-dibromobenzene. So you will replace 1,3 here with meta. And then we have, look, the position of bromine now at position 1,4. So you can write either 1,4-dibromobenzene or para-dibromobenzene. So we replace 1,4 here with P. P stand for para. Okay, how about if we have two different substituents like this? Okay, so you need to select one of the substituent that give new parent name and number it as C1. Okay, for example here we have two substituent. We have COOH and NO2. So just now we know that COOH when directly bond with benzene, it has common name. Bila dia ada common name, guys, common name tersebut boleh jadi sebagai parent name. Boleh nampak tak? Dan kita akan letak dekat carbon sini adalah carbon number 1. Okay, so our parent is benzoic acid. Nampak tak yang saya birukan tu? Okay, so nama dia adalah 2-nitrobenzoic acid. Or you can write as orthonitrobenzoic acid. Clear, guys? Very simple. Okay, so the other version here. Okay, so kita ada here CH3 as substituent and chlorine as substituent. So which one? Macam mana kita nak pilih ni? Just now we know that when CH3 directly bond with benzene, we have the common name, right? So kalau dia ada common name, terus ambil dia sebagai parent name. So our parent name here is toluene. So if you number the benzene, we start number 1 at carbon that directly bonded with CH3, and then kita pusing dengan carbon yang lebih dekat with the other substituent, which is chlorine. Okay, so look at the position. So we have 3-chlorotoluene. Nampak tak? Okay, tak perlu nak letak 1,3 lagi dah. Okay, so or you can write as meta-chlorotoluene. Okay, boleh kelas? Okay guys, how about if you have tri or tetra substituted benzene? Tri means 3 substituent. Tetra, it means that we have 4 substituent. How? So, if you have more than 2 substituent, okay, so you need to consider this priority. Yang sebelah sini. Okay, so carboxylic acid is the highest priority become your parent name. Paling rendah adalah alkane dengan halide, alkyl halide. Okay, so you need to consider this priority as to choose which one is your parent name. Okay, I give you the example here. Okay, before that we look at this statement first. The position of substituent must be indicated by number, lowest number as possible. Okay, saya dah pernah bagi tahu ni. Okay, kedudukan substituent kalau boleh pada nombor yang agak rendah. So the substituent are listed alphabetically when writing the name. Okay, so kena ikut alphabet bila nak susun tu kan, sebab kita ada banyak substituent. Do not use ortho, meta, para. So remember, ortho, meta, para only for benzene that consists of 2 substituent only, or di-substituted benzene. If you have tri or tetra substituted benzene, you cannot use ortho, meta, para. Clear? Okay, next we look at this example. We have 3 bromine atom directly bond with benzene. Look at this compound. So if you start numbering the benzene, we need to start with the kawasan yang lebih banyak substituent. Okay, So saya start daripada atas, 2, 3, 4, 5, 6. See? Okay, so cara you namakan, dia akan jadi 1, 2, 4 tribromobenzene. Tri, it means refer to 3 bromine atom. Okay, clear? So we cannot use ortho meta para here. Okay, next we have chlorine, bromine, iodine. So dekat mana you nak letak nombor 1 kelas? So you akan letak number 1 either at carbon directly bond with chlorine or carbon directly bond with iodine. Which one? Bila you kena buat pilihan macam ni kelas, you kena consider dari segi alphabet. This one is chloro, this one is iodo. So mana dulu? C dululah, kan? So we put number 1 here. Number 2 kita akan letak di bromine sebab kalau boleh lebih dekat, kan? 3, 4, 5, 6. So when you want to write the name, you need to kena susun ikut alphabet kelas. Okay, so we start with bromine first. 2 bromo, 1 chloro, 3 iodo, benzene, like that. Okay, next, if the carbon atom bearing the substituent that define the new parent is numbered as C1. Okay, for example here, okay, we have 3 substituent here. We have OH group, NO2, NO2. Okay, so as we know that if OH directly bond with benzene, we have the common name, right? Nampak tak? Kita ada common name. Apa common name dia? Phenol. So bila kita ada common name dekat sini, maksudnya dia akan jadi parent name kita. So you akan letak nombor 1 dekat carbon that directly bond with OH. And then you akan pusing clockwise yang terdekat dengan substituent. So the name should be 2,4-dinitrophenol. Nampak tak? Phenol. 6 common name yang saya suruh you hafal tadi, kan? Okay, next. How about this one, guys? We have COOH, OH group, OH group. So we have 3 substituent here. So we have 2 common name actually here. We have benzoic acid boleh or phenol pun boleh. Betul tak kelas? So bila you kena buat pilihan macam ni sebab common name ada kedua-dua dalam compound ini. So bila you kena buat pilihan, you kena consider dari segi priority ni kelas. Sekarang kita tengok alkohol, OH kan alkohol, carboxylic COOH. So mana priority yang paling penting? Paling tinggi priority dia carboxylic lah. So carboxylic menang. So we put number 1 at carbon that bond with COOH. Okay, and then that's why the parent name should be benzoic acid. COOH menang lah, bukan phenol Okay, so 3,5-dihydroxy benzene. OH kalau jadi substituent, nama dia hydroxy. Okay, jangan silap. Okay, next. Here we have 2 chlorine atom and NH2. So we know that if NH2 directly bond with benzene, we have common name which is aniline. So that one should be your parent name. So we need to put number 1 at carbon that bond with NH2. Pusing yang paling dekat dengan substituent. Okay, so you dapat 2,5-dichloroaniline. Boleh. Okay guys, how about if benzene as substituent? Boleh ke benzene ni jadi sebagai substituent? Boleh guys. Nama dia adalah phenyl. If benzene as substituent, the name should be phenyl. When benzene can become a substituent? Like this. If the alkyl substituent is larger than ring or more than 6 carbon, the compound is named as phenyl. Okay, look. So here is the substituent, right? So we have 1, 2, 3, 4, 5, 6, 7. More than 6 class. Tengok. So if more than 6 carbon, the longest change mengalahkan benzene. Benzene cuma ada 6 je. Nampak tak? Okay, yang ni cuma ada 7. So siapa yang menang? So confirm lah yang 7 carbon menang. Okay, so apa yang berlaku? Benzene akan jadi substituent. So nama dia akan jadi 2-phenyl heptane. Heptane alkane kan. Phenyl refer to the benzene ring as substituent. Okay, the other example here, if the chain is unsaturated, means the chain, the straight chain here consists of carbon-carbon double bond or carbon-carbon triple bond or contain important functional group. So benzene will consider as phenyl substituent like this. Okay, so walaupun number of longest carbon chain here, the straight chain carbon here 1, 2, 3, 4, only 4 carbon, but inside this carbon chain consists of triple bond, so dia menang. Dia ada important functional group dekat situ, so dia menang. Okay, so dia akan jadi parent kat sini 1, 2, 3, 4. Nampak? So nama dia adalah 1-phenyl 2-butyne. Butyne ni tak termasuk dalam syllabus you all lah, tapi sajalah belajar kan. Okay, and then the other version, look, here the straight chain carbon, we have only 2 carbon, but we have the important functional group here, OH group. So dia menang. So benzene will be your substituent. So this is your parent chain 1, 2. Why we put number 1 here? Because carbon, this one carbon bond with important functional group, OH group, number 2. So at carbon number 2 we have phenyl as substituent. So nama dia adalah 2-phenyl ethanol. Boleh nampak? So kita dah belajar chapter 8 punya syllabus.
Next, we look at benzyl group. Benzyl group is benzene directly bond with CH2. CH2 tau, bukan CH2CH3. Okay, so sekarang ni kalau CH2 that bond with benzene attached to chlorine, we call as benzyl chloride. If we replace the chlorine atom with bromine atom, so dia jadi benzyl bromide. So if we replace with OH group, chlorine tu kita gantikan dengan OH group, so dia jadi benzyl alcohol. Nampak tak kelas? Okay, so ini adalah the other version of naming aromatic compound.
Okay guys, finish about nomenclature of aromatic compound. Now we look at chemical reaction of aromatic compound. So this is the chemical reaction of benzene and its derivative. Okay, so we start with benzene here. So as we know that class, if you still remember, in chapter 4.4, I already explained about the type of reaction involved in aromatic compound, which is the type of reaction is electrophilic, aromatic, substitution. Substitution, what it means by substitution? So ada yang keluar, akan ada yang masuk. Okay, kat sini saya guna benzene yang bentuk bulat. Kalau nanti you all guna benzene yang ada 3 double bond tu, boleh So we know that each carbon here consists of 1 hydrogen. Kan, saya lukiskan sebab I want to show to you that akan berlakunya substitution reaction. Okay, so we have 4 main reaction in benzene ring. So I will explain to you one by one. So we start with nitration. Okay, nitration. So look at the reagent that we use here. So the reagent that we use here is concentrated nitric acid with concentrated sulfuric acid at the temperature 50 to 55 degrees Celsius. So what happened? Tengok saya dah kata substitution. So maksudnya one of the hydrogen will remove and replace with nitro group. Okay, contoh hydrogen dekat sini kita akan keluarkan dan kita akan gantikan with NO2. Nampak tak? Why the side product is H2O? Later kita akan belajar lah. Boleh? Okay, next we have halogenation. Okay, if halogenation, apa yang berlaku? Kita tengok dekat sini. Ni saya padam sekejap nak tunjuk. Alright, so you akan react dengan halogen. Halogen kita either bromine atau chlorine. X kat sini sama ada Br2 atau Cl2. So here kita ada catalyst. So catalyst kalau kita guna Br2, catalyst kita adalah FeBr3. Okay, ataupun kalau you guna Cl2 dia akan jadi FeCl3. Okay, so what happened here class? One of the hydrogen will remove and replace with halogen atom. So kita tahu tadi satu hidrogen keluar, so dia gantikan dengan X. X ni either chlorine or bromine. So hidrogen yang keluar tu dia akan combine dengan the other bromine atom or chlorine atom yang lagi satu. Boleh nampak? Okay, so very simple. Okay? Okay, next kita ada Friedel-Crafts acylation. Friedel-Crafts acylation. Acyl group tu adalah C double bond O class. Kat sini saya bagi general je ni. So sebenarnya contoh R dekat sini, R ni adalah alkyl group. Alkyl group kita dah belajar, ada methyl, ada ethyl, propyl, isobutyl, banyak kan. So contoh dekat sini saya gantikan CH3 C double bond O Cl. Ni contoh R. Okay, so saya gantikan R kat sini adalah CH3. So what happen class? So dia akan break dekat sini. So one of the hydrogen yang keluar daripada benzene tu akan combine dengan Cl. So dekat mana putus, dekat situ awak sambung balik. So dia akan dapat ni ketone. Okay, so R kita tadi adalah CH3. Nampak? So one of the hydrogen yang keluar tadi combine with chlorine yang kita dah putuskan tadi. Boleh? Okay, kat sini juga ada catalyst. Catalyst yang kita gunakan adalah aluminium trichloride. Okay, next kita ada Friedel-Crafts alkylation. Alkylation tu maksudnya we are going to substitute into benzene with alkyl group. Okay, so ingat R tu adalah alkyl group. Dekat sini dia tulis R je. So contoh kat sini saya bagi dia adalah CH3Cl. So maksudnya dekat sini apa yang berlaku? CH3 dengan Cl tu akan break. Dia akan break, so kita akan masukkan CH3 dalam benzene. So Cl yang keluar ni akan combine dengan hydrogen from benzene become HCl. So we have the catalyst here, aluminium trichloride also. Okay, be careful kat sini guys. Nanti we learn about the mechanism. This step, Friedel-Crafts alkylation, these R can rearrange if the primary alkyl halide is used. So you already learned about the rearrangement in alkene. Okay, so ni nanti kita akan belajar lebih lanjut. So this is the 4 main reaction involved for benzene ring. Okay, so all these 4 reaction, the type of reaction is electrophilic, aromatic, substitution. Clear guys? Okay, so the other reaction of benzene, kita ada satu lagi reaction, dua lagi reaction, iaitu reaction of alkyl benzene. Maksudnya bila you dah dapat produk dekat sini kelas, ini adalah alkyl benzene. Nampak tak? Alkyl group bond with benzene. So we call as alkyl benzene. So this alkyl benzene can undergo further reaction. Dia boleh pergi lagi reaction. Okay, contoh reaction yang pertama dia boleh buat adalah oxidation of side chain. Okay, and reaction yang kedua adalah halogenation of side chain. So this reaction will undergo free radical substitution reaction. Okay, so how? Look at this example. Okay, so kita akan guna reagent CmNO4H plus heat. So this is the reagent that we use. So this is the reagent that involve in oxidation of side chain. So what happened to R group ataupun alkyl group? So the whole alkyl group will change to COOH. Nampak tak kelas? R ni akan totally change become COOH. It means that this alkyl group will undergo oxidation form COOH. Nampak tak? Daripada alkyl benzene boleh tukar jadi benzoic acid But remember class, we have condition here. What is the condition? Okay, the carbon atom that bond with benzene must have at least one hydrogen atom or benzylic hydrogen. Macam mana pula ni? Okay, I'll show you the example here. Contoh benzylic hydrogen yang kita ada adalah, okay, contoh dekat sini saya bagi ini adalah awak punya benzene ring, and then kita ada CH2 CH3. Nampak? So yang mana adalah benzylic hydrogen? Yang ini kelas. Hydrogen ni dipanggil sebagai benzylic hydrogen because this hydrogen directly bond with carbon and that carbon directly bond with benzene. Nampak tak? So bila hydrogen tu bond with carbon that directly bond with benzene, that hydrogen we call as benzylic hydrogen. While this hydrogen is not benzylic hydrogen because that carbon not directly bond with benzene. So itu syarat dia. So the whole alkyl group here will change to COOH. See? Okay, I give you the other example here. Contoh lain, kalau awak ada, okay, ni benzene, okay, and then you ada CH3, CH3, and then here also CH3. Okay, boleh tak this alkyl benzene undergo oxidation of side chain? So this one, boleh tak? Tak boleh class, because this benzylic carbon, carbon yang bond with benzene, tidak ada benzylic hydrogen. So this alkyl benzene cannot undergo oxidation of side chain. Tak boleh. So what happen? No reaction lah. Nampak class? Okay, and the last one, we have halogenation of side chain. So what happen here? Okay, so dia akan dapat ni nampak X2. X2 refer kepada halogen. Okay, X ni refer kepada halogen sama ada Cl2 or Br2. So you pernah jumpa kelas reaction ni, bila ada UV dia refer kepada free radical substitution. So apa yang berlaku, H akan keluar dan akan substitute dengan halogen. Contoh kalau kita ada kat sini tadi saya ada bagi CH3. So what happen kalau undergo halogenation of side chain, one of the hydrogen at carbon tu dia akan keluar, so dia akan tinggal CH2. So contoh kalau kita react dengan klorin, so dia akan masukkan 1Cl. Like that. Very simple. So dia akan terlibat dekat side chain. Side chain tu maksudnya dia terlibat dekat branch. Reaction tu hanya berlaku dekat branch sahaja. Boleh tak kelas? Okay, reaction tu hanya berlaku dekat branch sahaja. Okay, so dekat sini ada a little bit info. Alkyl benzene with R group longer than CH3 are ultimately degraded to benzoic acid. Maksudnya kelas, kalau R ni ada 100 karbon sekalipun, nampak R ni ada 100 karbon sekalipun, tapi dia ada satu benzylic hydrogen, so the whole 100 carbon just now will totally change become COOH. Nampak tak? Betapa canggihnya oxidation of side chain, dengan syarat dia ada benzylic hydrogen. Okay class? Okay, that's all for aromatic compound. I will see you in mechanism of aromatic compound. Bye guys. Thank you.